Hey guys, welcome back. In this lesson, we're going to get our player moving around the level based on our input. So we're going to be able to hit the W, A, S, and D keys, the arrow keys, or even use a controller's analog sticks to move our player around. Unity makes it very simple to use all three of these different types of input without having to worry about each individual one. So we're going to move the player around. We're going to calculate the movement based on our input, like I said, and we're going to be colliding with objects like the walls, the enemies, and the coins using our collisions with rigid bodies. And we'll talk about exactly what that is here in just a second. So back in Unity, the first thing I want to do is I want to go to my scripts folder and I want to right click and I want to create a new C# script that's going to be called player. This is going to handle everything our player does. Now, as we know, all I have to do is go to my player object, drag my player script file directly onto my player object, and now anything we write, we can actually talk to this object and talk to the components on this object. But the important thing we're going to be using for this is what's called a rigid body. Now, outside of physics, all we have to understand is this allows us to be physically enabled, so we can apply gravity, we can apply collisions and force, and all those things you get to do in real life, right? If you pick up your phone and you throw it across the room, you applied force to it, and then it's going to collide with the floor, and then it's going to stop moving, right? So we can do that with these objects by using something called a rigid body. So I'm going to add a component. I want to add a component called Rigidbody, not the 2D version. Make sure you have the regular version. And now this gives us some physical components, some physical attributes. But all I care about for this is going to be the mass of the object. So how heavy is this object? And we'll tweak this as we go and we add jumping and stuff. And also the fact that we are using gravity, so we're going to be applying a downward force to this object. Now with this setup matched with a box collider here, whatever kind of collider you have, we should be able to physically interact with our world. So let's test this out. What I can do, just to play around with this, is I can just grab my player, I'll drag him into the sky here. And now if I were to click play, what we should see is our player falling to the ground. That's pretty cool, right? So if I were to grab the player again while it's simulating, I can drag it up and it'll fall to the ground. And that's what we're going to do to work with this. Now if I try to drag him through this wall, notice he collides with it and he freaks out, right? That's because what I'm doing is I am manipulating the physics without editing the physics itself. So I'm actually dragging this object, I'm forcing the object around, and in this game world, it's ruled by physics. But I'm saying, no, I don't care about your physics. I control this object. So it freaks out. So we have to use physical attributes to control the object. And by that I mean we have to use the physics engine to move the object around. So we have to apply force or velocity. So if we want to apply a velocity, we'll apply the velocity to our player, which just means the speed and direction it's going to be moving based on our input. So if we're holding down the left direction, we're going to apply velocity that'll move the player to the left. Then if it finds a wall when it's going to the left, it'll collide with it and not be able to move beyond it. Any direction we want to move, we'll calculate the velocity for that direction. And one thing that's pretty cool, if I were to take this and angle it, just give it a weird angle here, and now click play, what we'll see is it kind of bounce about. Pretty cool. So now player, the script file that is a component on our player object, it has a box collider component, a mesh renderer component, a cube mesh filter component, and a rigid body component. Now for this, we're going to be using the rigid body and the box collider components directly in our script. So what I want to do is I want to open this up in Visual Studio. So I'll just double click on player and then we'll launch it in Visual Studio 2017 in my case. So to set the velocity property on the rigid body, we have to have a way to talk to the rigid body that is in fact on the player, right? It's on the same object our player script file is. So it's not too hard to get a reference directly to the rigid body because it's also on this object. So what I'll do is I'll create a private variable that will hold a reference to the component that's on this object that is a rigid body. So I'll create a private Now, the type of variable is the component type, and it happens to be a rigid body, right? That's the type of component that we want a reference to. So I'll say a private rigid body, and I'll just call it player body. So player rigid body, or whatever you want to call it, anything other than lowercase rigid body, as that's something that Unity will have a problem with. So if I type rigid body in here, it'll say it hides rigid body. Now, and that's because back in the day, Unity had a direct reference to the rigid body component on any object by just using this variable here that they already defined for us. Now, we don't use that because it is obsolete, it is out of date, it is no longer supported. So we create our own reference to rigid body, and I'll call it player body. And what I'll do with player body is in the start method, which happens whenever this object is created, as we saw in the original 101 series. When that happens, I can say player body is equal to, so I can assign the value of the variable to be the rigid body on the player. Now that component, we can get it by doing a method called getComponent, just like that. Now it wants to know what kind of component we want to get, what type of component we want to get. And to do that, we will place our type inside of these two angle brackets here, so less than, greater than. Right inside of that, we'll place the type of component we want to get, because the get component can accept any type that is valid. So what type do we want? I'll say rigid body. That's what we want. That's what our player variable is. That's what this variable wants. That's what get component will look for. Now this is also a method, so we have to end it with the parentheses, as we know. Now this is called a generic method. That's because beforehand, it doesn't know what type of object to look for. It just accepts any type of object. So we have to pass in, this is the type of object you want. You want a rigid body object. And then the method's like, oh, okay, I'll hunt a rigid body type of object as a component on this object. If I find one, I'll return it to this position so we can assign it to the player body. And we know for a fact it will find one because a rigid body is on this player. So now player body references the rigid body on our player. So player, rigid body. Now one way we can see this is I can expose this value to the inspector. So you know how the public values, the public variables, we can actually edit in the inspector very easily? Well, that's fine, but you don't want to make everything public. There's just no reason to do that. You don't want everything to be accessible to everything. That can cause some issues later on if you're not exactly sure what you're looking for and you just have all the available options to you. You want to make sure that you only expose things to each other that each other needs to use. And that's a good sign of a good, a well-written game or well-written program is understanding when and what needs to be exposed where. So while this is private, it cannot be accessed by anything outside of player, which nothing should access it. What I can do is I can tag it with a serialized field attribute, which is simply going to say, hey, the inspector should be able to use this to serialize it so we can see it in the inspector. And no more than that is needed for this. It's an attribute. We're not going to go into any more detail about it. That just allows us to see this in the inspector while it's private. There it is. And it says, hey, I'm looking for a rigid body. Now, what I could do is drag rigid body and drop it directly in there. And that's one way to assign the reference. I would no longer need player body is equal to get component rigid body. But we want to do it a bit better. So we're going to say none on that. And now when I click play and the object is started, it'll grab that reference using the get component thing we just wrote. There we go. Pretty cool. So you can see there's two ways to go about that. Very easy. Now that we have that reference, what we can do is we can actually update the position using velocity. So if I were to play around with this in the update method here, I could say player body dot velocity. That is the velocity property that is a vector 3. So it takes a X, Y, and Z. So what direction are we moving in and at what speed? So I can say the velocity is equal to vector 3 dot right. Now we know that's going to give us a right vector. And if we try this, my player should just move to the right at a slow speed at 1 because the vector is going to be 1. There we go. moving to the right. Now, the reason it's no longer falling to the ground is because we are overriding the velocity to match our right velocity, which includes 0 on the y, right? So we're going to change this and create a new vector3 object that we can create and construct a new vector with and pass in our own x, y, and z. I could say the x would be 2, the y would be 0, and this would be 2 as well, maybe. We'll just move in that direction. There it goes, moving in that direction. But we're still not falling on the y. So one way we could do that is I can grab the current velocity of the y by going playerBody.velocity.y. So we'll not override the velocity for the y value. We'll just use the velocity for the y value. Let's try that out. There we go, and it falls to the ground, and it's going to tumble over because we're adding that velocity to it, which works with the physics engine, right? So we're not overriding the physics like if we were to grab the object and move it manually. That freaks it out, as we know. See if we can, okay. Yeah, he's gone. So, oh, he's up there now. There he is. Pretty cool, right? So that's how velocity works. And we're going to use that to move our player around using our input. So how can we do that? Well, we have to get our input first, and we could do that very easily. What I want to do is I'll have a private variable here. It's going to be a float. It's going to be our input on the x. So how much do we move left and right? So I'll say input x. Then we'll get an input for the z, the forward and backward. So I'll have a private float input z. But what you're probably seeing here is, well, we have x and z, and we'll have y for jump. So it's already got a vector format going on, so we could probably just convert it to a vector, right? And I could, in fact, just say private vector3 variable type here, input vector. And this will take the input x, then the input y, and the input z, and so on. So we'll just use that as our input vector. And the way we're going to do this is every frame we're going to check to see, am I holding down a button that will be moving in a direction? If I am, we're going to use that to control the value of this vector. So how do we do that? Well, I'll say input vector is equal to, and again, we'll create a new vector3 here, and it's going to take an x, y, and z. So there we go. We can just take the x value, and instead of passing in a 1 or whatever, we'll pass in the horizontal axis input, which means if I'm holding down left, it'll be a -1 value. If I'm holding down right, it'll be a +1 value. If I'm not holding down anything, it'll be 0. And that gives us exactly what we need to understand what direction to move in, right? Because if x is 0, we're not moving on the horizontal axis, so the velocity on the x should be 0. Now, to give us an example of this, I'll comment this out, and that just means that this is no longer going to be processed by the computer. This is just for us to see now. What I can do is I can print out some values here. I can print out, let's just grab, I'll talk about this here in a second, but I'll just grab the axis I'm talking about of horizontal. And we'll use this here in a second for movement, but I want to show you what this does. So in the console, it's printing out 0. We're not moving at all. Now, if I were to hold down left, see what's happening? It goes from 0, let's clear that again. It goes from 0 all the way up to -1, or all the way down to -1. Let go, we go back to 0. Let's turn off collapse so we can see it happening here. So 0, left, -1, let go, 0, right, +1. Okay? It works the same for the vertical axis up and down as well. +1 up, -1 down. So we'll be using that to calculate our input. So again, we'll go through the method called get. We'll go through the class called input, which gives us a method called get axis. Now we have get axis and get axis raw. Get axis will do what we just saw, that goes from 0 to -1 progressively, whereas raw will snap from 0 to 1 directly. Now, in this kind of movement, I do like having the snappy, fast movement, so I'll do get axis raw, and the name of the axis that we want to use is horizontal. Now, this is defined in the Unity Input Manager. So what does that mean? Let's go into Unity, go to Edit, Project Settings, and go to Input. We have an error because we didn't finish our vector, but that's fine. Now we have axes here, and we have 18 total. Now we won't be using most of these, But we have horizontal and vertical. These are the names. We can change them if we would like. We can change what buttons do what, but they're just defined in here for us to use. So we'll be using them. Now for the Y value, as we know, we want to add the gravity that's already there. But for now, I'm simply not going to worry about it. I'm just going to set 0. And then I'll do input again for the up and down movement. Get axis raw. And I want the axis name is vertical. That'll be WS, up and down arrows, or even analog stick up and down. Now all I have to do, and you probably guessed this by now, is use the input vector as the velocity for the rigid body because it has the direction in vector form that I want to move in. So I'll say player body dot velocity is equal to input vector. Just like that. Now we'll be moving at 1 speed on each axis, but that's fine. We can speed it up if we would like. Let's go back into Unity and click play. So with it being 0, I'm falling slowly to the ground, but I can hold and move the arrow keys in the direction I want to move. So with that falling effect that we're having there, we know that we can fix it by doing player body dot velocity dot y. Fall to the ground, and now I can just move around. Now that I am stuck to the ground though, it's just going to tumble about. So one way to fix this problem that we're having is I can go to the player object and I can go down to constraints. Now this allows me to say you cannot do this on this axis. So I want to be able to move on every axis, so we don't want to restrain that or constrain that. But I want to rotate only on the y-axis, the y being up and down, so we can look around in the directions. But I don't want to be able to tumble around because that's just not how this game is going to play. So check those off so we do not move or rotate, on the X and Z. And with that said, we'll grab the player, we'll rotate it 0, 0, 0, and position it again at 0.5. Now there I am, left, right, up, down. Okay, so that's cool. But clearly we're moving too slowly. So what I want to do, this is very easy to do, is I could just take and multiply the input vector for the horizontal by, say, 10. We'll increase it by a multiplier of 10. And same for the vertical, multiply it by 10. Now we're not multiplying the y value because it's gravity, and we move at 10 times the speed of gravity. That could cause some issues. But there we go. Now I can move about in a pretty nice, snappy manner. But one thing you'll notice is no matter what direction I am going in, I am looking in the same direction. And that's probably fine for your game, but what I want to do is I want to rotate like you would expect if you're walking around in this world to look in the direction you're moving. So to do that, we'll use a method. Let me zoom out a little bit here. We'll use a method called lookAt from the transform component. So transform.lookAt. Now this allows us to pass in a target to look at or a world position to look at, and then some other options here. Now all I care about is the world position to look at. That's because I can say, hey, I'm moving in this direction. This is the vector I'm moving in. Use that to calculate the direction you should look in. So the first thing I have to do is I have to take the player's current position. The reason I have to take the player's current position is because we're moving about in the world, and this is using a world position. So we have to create the starting position, which is going to be wherever the player is, and then we look out in the direction that we're moving in. So then what I'll do is I'll just add to that a new vector 3. Now this vector 3 will be very similar to our input vector, except we won't have to worry about the y. So what I'll do for that is I'll just take this, highlight it, hit Control X to cut it, and I'll paste it below input vector. So we can take input vector and use the x value, not the z value, or not the y value, but then use the z value. So the x value of our input vector, the z value of the input vector, and nothing on the y. Now if we do this, what happens? There we go. So I'm snapping and looking in the direction that I'm moving. Now you're getting that snap because, first of all, you're using the raw axis. And second of all, because we're using the keyboard and not an analog stick, which would give us the positions in between. So what happens if we change this to be not the raw version, but the regular version? There it is. It's a much smoother movement for the keyboard. And the last thing we have to do for the basic movement is we have to think about what's going on here. So I'm calculating the input here, which is fine. And then I'm looking in the direction that I should be moving. And again, that's fine. But then I'm doing something with the velocity of the player body. And one thing I want to do for that is I want to make sure this is calculated on what we know as the fixed update. So it's only calculated 50 times per second, the same rate as every other physics-related thing in our engine, right? So if I were to take this, I want to do this in fixed update. Now, we talked about fixed update in the previous course, the 101 course, but it simply happens at a fixed time step of 50 frames per second, whereas update happens no matter how many frames per second you have. If you have 120, if you have 240, if you have 60, this happens at the same rate every time. So this is where you should be calculating all of your physics, just like we're doing here. And we will be doing more physics calculations within fixed update in future lessons. That's going to be it for this lesson, guys. My name is Austin, and I will see you in the next one.